This is the charge tape lab. The first thing that is important to go over is the purpose of this lab. The purpose is to determine the charge of a tape of a given length. It's also important to observe the interactions between charged and neutral objects and observe the interactions between charged and similarly or oppositely charged objects. Notable models that were used were Coulomb's law, the force of gravity equations, and Newton's second. The results of this lab were as such. The charge of the top tape, which was determined, was 1.12 times 10 to the negative 8 coulombs. The number of excess electrons was 6.99 times 10 to the 10 excess electrons, and the ratio of excess electrons to atoms was 4.66 times 10 to the negative 13 to 1. Going more into those fundamental physics models that were used is Coulomb's law. Coulomb's law states that the force of on a charged particle due to another charged particle is equal to k times the charge of the first times the charge of the second over the distance between them squared. This is important because if we model these two tapes as charges, then we can use this equation to find that force. We also use the force due to gravity, F equals mg. We can assume gravity is a relative constant on Earth as 9.8 meters a second squared. From this, we can figure out the opposing force and help figure out the charge considering all these other factors. Doing this, we use Newton's second, which states that force equals mass times acceleration. Since the tape is not moving, we can conclude that the force net must equal zero. Therefore, we can set Coulomb's law and force of gravity equal to each other and start getting some answers as to the charge of the top tape. In order to figure this out, we created the following set. We created two posts that were connected by the piece of tape on the top. That was approximately 0.2 meters long. This tape was brought over a similarly sized tape and was suspended between two posts. The bottom tape was brought closer to the top tape until the top tape began lifting above its original position, and then the distance at this point was measured. In another experiment, the charge was determined to be positive because the tape was first suspended off the edge of the table and was brought near a negatively charged pen. Since it attracted this pen, we can conclude that the direction of charge, or rather the sign of charge on this top tape must be positive, because if it was negative, it would have repelled the negatively charged pen. There was assumptions made about this lab, one of which was that the approximate mass of this tape is 1 gram per meter. This was used to calculate the mass of the tape, which will be used later in calculations. It was also assumed that the width of this tape was constant at 0.015 meters, and the thickness was constant as 5 times 10 to the negative 5 meters. Another big assumption is that the charges were evenly spread across this tape, and each tape had the same amount of charge. This is a big assumption that could lead to some error. There's also a big assumption that these tapes could be represented as point charges, despite them being irregular in shape. This can lead to some possible errors because the charge is not evenly distributed, considering the tape is an insulator. So this assumption will lead to some significant error. The dimensions and mass may also have not been correctly assumed because they were not measured, and discrepancies in this might lead to some significant error. There's also the possibility of accidental grounding of the tape by contact with people or objects, which would remove some of the charge before the experiment could be carried out. Results: the separation distance, that is the distance at which the top tape began getting lifted by the bottom tape, was 0.024 meters, and the tape dimensions were, from the assumptions above, 0.2 meters, 0.015 meters, and 5 times 10 to the negative 5 meters. Therefore, calculations can be carried out to determine that the charge, as seen in the right, is 1.12 times 10 to the negative 8. The number of electrons can be calculated by dividing this charge by the charge of an electron, leading to 6.99 times 10 to the 10 electrons, and then the amount of atoms can be calculated by getting the volume of the tape and dividing that by the Armstrong volume, which is 1 times 10 to the negative 10 to the third. Putting these over each other, we can get the final ratio of 4.66 excess electrons to atoms. A glow script code was written to verify these results. This led to a similarly calculated 1.12 times 10 to the negative 8 coulombs required for suspension, which is the same as the value calculated before. This was carried out by very similar formulas as before, and the proper code for this can be seen on the right. Further questions that should be answered include, what if the electrons had positive charge and protons had negative charge? If this was happened, the observations should be exactly the same, because everything that is charged positive will now become equally charged negative, and everything charged negative will be equally charged positive, and the magnitude of these two results would end up being the same. It is important to handle the charged tapes as little as possible, because contact with the charged tapes can lead to grounding, which would take some of the charge off of these tapes and lead to incorrect results.